Good morning, my name is Teresa Palominos-Rizzo. Today I'm going to present one of the articles carried out during my doctoral research at the University of Costa Rica. The title is Estimation of Soil Moisture through Multiple Linear Regression in Llano Brenes, Costa Rica. Soil moisture is a very important variable in the supply of water for agriculture, and it is its main resource. However, its measurement in the field tends to have limitations, so its prediction is necessary for various agricultural planning and research activities. The objective of this study was to predict daily soil moisture at the crop scale, based on meteorological information using multiple linear regression models. The study was developed in Llano Brenes, Alajuela, Costa Rica. The precipitation regime has a well-defined dry season and a rainy season. The rainy season corresponds to the months of May to November. Time-domain reflectometry TDR sensors were installed, and they record information every 20 minutes of soil moisture from November 2018 to December 2019. The soil was taxonomically classified as lithic ustertens in a farm with coffee cultivation in production. On the storm, soil samples were taken for TDA calibration, and a temporal stability analysis was performed. We carried out three models. The first model was a multiple linear regression with meteorological variables such as ambient temperature, minimum and maximum temperature, relative humidity, wind speed, and accumulated rainfall. In the second model, in addition to the meteorological variable, the precipitation was grouped into subperiods, which were introduced as dummy variables, while the third model consists of a principal component analysis and a linear regression models. Regard to the result, for the first model, with a multiple linear regression with the meteorological variables, we obtain a coefficient of determination of 0.54. The coefficient for daily accumulated rainfall, wind speed, and relative humidity in this model were significant and have a significant influence on the distribution of soil moisture over time. For the second model, all meteorological variables and subperiods were used. The subperiods were entered into the model as dummy variables. A coefficient of determination of 0.84 was obtained, which shows that the precipitation regime classified in subperiods is an important variable. For the third model, in multiple regression, two numerical values which were two principal components were used as predictor, which while subperiods were included as dummy variables. The model obtained a coefficient of determination of 0.82. The second and third models present a better performance compared to the model number one. However, the second model was considered more useful due to its simplicity and because it presents the best goodness of fit indicators. In conclusion, linear regression model with meteorological variables allow estimating for soil moisture. This because soil moisture tends to follow seasonal patterns and variation in precipitation, as observed in the second model with the separation of subperiods. The variables that best explain the second model were relative humidity and precipitation grouped into subperiods. Thank you very much for your attention.